Hello guys, in today's video we're going to take a look at some common petroleum engineering interview questions and answers. Why did you choose petroleum engineering? I've always been fascinated by the oil and gas industry and its impact on our society. I believe that petroleum engineering offers a unique combination of technical, economic, and environmental challenges, making it an exciting and rewarding field to work in. Additionally, I'm very excited to apply my problem-solving and analytical skills in a practical and impactful way. Can you explain the difference between upstream, midstream, and downstream sectors? The upstream sector deals with exploration, drilling, and production of oil and gas. This includes locating reserves, drilling wells, and bringing the hydrocarbons to the surface. The midstream sector involves the transportation and storage of oil and gas. The downstream sector focuses on the refining of hydrocarbons and then the distribution and marketing of the petroleum products such as gasoline, diesel, and petrochemicals. What's the role of petroleum engineer in the upstream sector? Depending on his position, a petroleum engineer in the upstream sector might be responsible for building and updating a reservoir model, designing and implementing drilling and completion operations, monitoring production, and designing intervention operations to improve production. Can you explain the difference between primary, secondary, and tertiary recovery methods in oil production? Primary recovery refers to the natural flow of oil and gas to the surface due to reservoir pressure. Secondary recovery involves injecting water or gas into the reservoir to increase pressure and push the oil towards production wells. Tertiary recovery, also known as enhanced oil recovery, involves injecting specialized chemicals, steam, or CO2 to improve the flow of oil and gas and increase recovery rates. Can you explain the difference between onshore and offshore drilling? Onshore drilling refers to the drilling activities that take place on land, while offshore drilling takes place in the bodies of water, especially oceans or seas. Offshore drilling typically involves more complex and expensive equipment, as well as additional safety and environmental challenges compared to onshore drilling. What's hydraulic fracturing? Hydraulic fracturing is a well-stimulation technique used to increase the oil and gas production from shale formations by injecting high-pressure fluid into the rock to create fractures, allowing the hydrocarbons to flow more easily toward the wellbore. Hydraulic fracturing has played a significant role in the petroleum industry by unlocking previously inaccessible unconventional oil and gas reserves and contributing to increase in domestic hydrocarbon production. What's drilling mud and what's it's used for? Drilling mud is a fluid mixture used during drilling operations to cool and to lubricate the drill bit, stabilize the wellbore, remove drill cuttings, and maintain wellbore pressure. It also helps prevent formation damage and blowouts by controlling formation pressures. What are some common well completion techniques? Well completion refers to the process of preparing a drilled well for production. Common well completion techniques include perforating the casing to allow oil and gas to flow into the wellbore, installing production tubing and equipment, and implementing a sand control method, such as gravel packing or installing a screen. In conventional reservoirs, it also often involves performing hydraulic fracturing to stimulate the well. How do you ensure safety during drilling and production operations? Ensuring safety during drilling and production operations often involves implementing strict safety protocols, regular equipment maintenance and inspection, employee training, and adherence to the industry regulations and best practices. Risk assessment, emergency response plans, and the continuous monitoring of operations also contribute to maintaining a safe work environment. What's reservoir simulation? Reservoir simulation is a computer-based modeling technique used to predict the future performance of a reservoir and to optimize production operations. It's essential for understanding reservoir behavior, estimating recoverable reserves, and making informed decisions about the well placement, production rates, and enhanced oil recovery methods. Can you explain the difference between proven, probable, and possible reserves? Proven reserves are oil and gas deposits that have been discovered and can be economically and legally extracted with a high degree of certainty. Probable reserves are deposits with a lower degree of certainty, but are also likely to be recoverable. And possible reserves are deposits with an even lower degree of certainty, and their recovery is unlikely. What is the role of petroleum engineer in downstream sector? In the downstream sector, petroleum engineer may be involved in the refining processes as well as design and operation of refineries and petrochemical plants. They may also work on quality control, product development, and the distribution of petroleum products. What are some challenges faced by the petroleum industry today? Some challenges include fluctuating oil prices, increasing environmental regulations, competition from renewable energy sources, aging infrastructure, and labor shortage. How do you stay updated on technological advancements and industry trends? To stay informed about the latest advancements and trends, I regularly read industry publications, attend conferences and workshops, participate in professional associations, and network with other professionals. What are some of the key factors to consider when selecting a drilling location? The presence and size of hydrocarbon reserves, geology and reservoir characteristics, accessibility, land ownership and regulatory requirements, environmental considerations, and economic factors such as costs and potential profits. How do you ensure environmental compliance in your work as a petroleum engineer? Ensuring environmental compliance involves staying updated on relevant regulations, conducting thorough environmental assessments, implementing best practices for pollution prevention and waste management, and continuously monitoring operations for potential environmental impacts. Can you explain the importance of reservoir management? Reservoir management is important for maximizing hydrocarbon recovery, optimizing production rates, and extending the life of the oil and gas field. It involves monitoring reservoir performance, analyzing production data, and implementing enhanced oil recovery techniques. What are some methods used to estimate oil and gas reserves? A few examples are volumetric analysis, material balance, and decline curve analysis. How do you handle the pressure and stress of working in the petroleum industry? I try to stay organized, setting realistic goals and priorities, maintaining a healthy work-life balance, and practicing stress relief techniques such as exercise or just going for a walk. How do you approach decision making in a fast-paced work environment? In a fast-paced work environment, I prioritize gathering accurate and relevant information, consulting with colleagues and experts when needed, and carefully analyzing the available data before making a decision. I also try to be flexible and open to adjusting my approach if new information emerges or circumstances change. What is enhanced oil recovery and why it's important? Enhanced oil recovery is a set of techniques used to increase the amount of oil that can be extracted from the reservoir. These methods, which include thermal, chemical, and gas injection, can help improve the recovery factor and prolong the life of the reservoir. Enhanced oil recovery is important because it allows the industry to maximize the value of existing reserves, reduce the need for new exploration, and decrease the environmental impact. How do you manage the risk associated with drilling and production activities? Managing risks associated with drilling and production involves combination of careful planning, technical expertise, and strict adherence to the safety protocols. This means conducting thorough geological evaluation, selecting appropriate drilling and production methods, implementing real-time monitoring systems. What's directional drilling? Directional drilling is a technique used to drill wells at an angle rather than vertically to reach specific target zones or avoid obstacles. This allows for improved access to oil and gas reserves, reduced surface disturbance, and the ability to drill multiple wells from a single drilling pad. Horizontal wells are often used in unconventional reservoirs, such as shale formations, where the hydrocarbons are dispersed throughout the rock, rather than being trapped in a single, easily accessible location. Horizontal drilling can improve the production rate and the recovery factors by increasing the wellbore contact with the reservoir. What are some common methods used for oil and gas exploration? Some common methods used for oil and gas exploration include seismic surveys, gravity and magnetic surveys, and remote sensing techniques. Seismic surveys involve using shock waves to create images of subsurface rock formations, while gravity and magnetic surveys measure variation in Earth's gravitational magnetic fields to identify potential hydrocarbon deposits. Remote sensing techniques use satellite imagery and aerial photography to detect surface features that may indicate the potential for oil and gas reserves. What is the role of a reservoir engineer? Reservoir engineer is responsible for analyzing and managing oil and gas reserves to optimize production and recovery rates. This includes evaluating reservoir performance, estimating reserves, designing production strategies, and monitoring the performance of production wells. Reservoir engineers also use simulation models to predict future reservoir behavior and develop strategies for enhanced oil recovery. What is well logging? Well logging is a process of collecting data about the subsurface formations encountered during drilling. This is the information such as rock types, porosity, permeability, and fluid content is important for determining the best production strategies. Well logs also provide valuable data for reservoir engineers when building reservoir models and predicting future performance. What are some challenges faced by petroleum engineers in the deepwater drilling? Some of the challenges are extreme water depths, high pressures and temperatures, and harsh environmental conditions. These challenges require specialized equipment and expertise in areas such as drilling, completions, and subsea production systems. Additionally, deepwater projects tend to have higher costs and longer lead times, making efficient project management and risk mitigation very important. What are some common types of drilling mud? Some common types of drilling mud include water-based mud, oil-based mud, and synthetic mud. Water-based mud is typically the most environmentally friendly option, but they may not provide the necessary performance in certain conditions. Oil-based and synthetic muds generally provide better lubrication and wellbore stability, but can pose a greater environmental risk. What is the purpose of well stimulation, and what are some common stimulation techniques? Well stimulation is used to improve the flow of oil and gas from a reservoir by increasing the permeability of surrounding rock. This is typically done by creating new pathways or enlarging existing ones for the hydrocarbons to flow through. Some common stimulation techniques include hydraulic fracturing, oxidizing, and thermal methods such as steam injection. What is a blowout preventer? Blowout preventer is a safety device used during drilling and completion operations to prevent the uncontrolled release of oil and gas from a well. It's designed to seal the wellbore and provide pressure control in the event of a kick, which is the influx of formation fluids into the well. BOPs are critical for maintaining the safety of drilling operations and protecting the environment from potential spills.